We're going to look at a few examples of solving quadratic equations by completing the square. We're going to start with probably the simplest kind, and then we'll add in some difficulty as we go to the other two. And I'll explain the different things as we go along. So here is a detailed list for solving an equation by completing the square. So here we go. The first thing we want to do is get the x terms on one side, on the left side, and the constant on the right. We're going to do this by subtracting 9 from both sides. And we will rewrite this x squared plus 12x is equal to negative 9. And notice I do leave a space here because we're going to fill something in that space. If the leading coefficient isn't 1, well, here's the leading coefficient, and it is 1. It's an understood 1. So we don't really have to do anything there. If it doesn't, yeah. Now we're going to do the completing the square phase. And I broke this up into a few parts. Multiply the linear coefficient. So here's the linear coefficient. Remember, 12x is our linear term. We're going to take the 12 and multiply it by a half and square it. So 12 times a half. You don't always have to show the work because this one's an easy one. 12 times a half is 6. And then we're going to square it. 6 squared. We're going to add that here. So multiply the linear coefficient by 1/2, square it, and add it inside the parentheses if there are any. There's no parentheses. The parentheses show up if we have to do this step up here. All right, if something's added to one side, so we just added 36 here, 6 squared, it must be added to the other side. So if there was no leading coefficient factored out, which in our case there wasn't, simply add the value from the step A to the right side. So we added 6 squared, which is 36, and so we added it to the left side, so we need to add that also to the right side. So we just completed the square. And so what we have here, what we learned is this right here factors into x plus 6 times x plus 6, or x plus 6 squared. That's why it's called completing the square, because we added something to make this a perfect square. So we have negative 9 plus 36 is 27. And now we're going to be on step 4, solve the remaining equation. If necessary, multiply both sides of the reciprocal, something that's factored out. There wasn't anything factored out here, so you don't have to do that. So next we're going to take the square root of both sides to cancel with the square root. To cancel with the squared. Make sure we put plus or minus here. And so the square root and squared cancel. We're left with x plus 6 on the left side. And plus or minus the square root of 27, well, we're going to simplify the square root of 27. 27, if you factor that, that's 9 times 3, which is 3 and 3. So the square root of 27 is 3 cubed. We can think of that as the square root of 3 squared times 3. And that simplifies to 3 times the square root of 3. So we simplify the square root of 27, and we get 3 root 3. And now we finish this off by adding or subtracting from both sides. So we subtract 6 from both sides. Now what we normally do for our answer here, obviously we have x equals on the left side. On the right side, we put negative 6 plus or minus 3 root 3. So we put this term first, the rational term first. And there's the answer to that one. Next one, we're going to complete the square. This is a little bit different because we have a 3 here. So we still start the same though. We want to get the x terms on the left side and the constant on the right side. So we add 7 to both sides. And we get 3x squared plus 18x is equal to 7. We'll leave that gap there, although we don't use it quite yet. Now, if the leading coefficient isn't 1, well, it's not. It's a 3. This is the leading coefficient. What do we need to do? Factor out the leading coefficient from both terms on the left side. So we're going to do that. And 3 factors out nicely from 18. It goes in there 6 times. And we're still going to leave that gap and close our parenthesis, equals 7. We're going to complete the square, so we're going to do steps A and B. So what we do, multiply the linear coefficient, 6, by 1/2. So 6 times 1/2, that's easy. 6 times 1/2 is 3. And we're going to square it by 1/2, square it, and add it inside the parentheses. So here the parentheses are there. I do like to put the 3 squared here, plus 3 squared, because that helps me in a minute. And now, if something is added on one side, then it must be added to the other side. We have to be careful here, though, because we added 9. The 9 was inside parentheses, and look what's outside the parentheses is a 3. So when we add a 9 in here, it's really being multiplied by 3. So we actually added 27, and that's what this is saying here. If there was no leading coefficient factored out, simply add the value from step 1. Well, there was something factored out, so we're not using this. If there was a leading coefficient factored out, in this case 3, multiply the value from step A, the 9, by the leading coefficient and add it to the right side. If there were fractions involved, you might need to get a common denominator. We don't have fractions, so 9 times 3 is 27, so we add 27 here. So we kept things balanced. We add the same thing to both sides. Well, over here on the left, we now have a perfect square. We still have this 3. And our perfect square is x plus 3. So we take this right here and put it here, and that thing is squared. And again, this whole thing factors to x plus 3 times x plus 3, or x plus 3 squared. Over here we have 34. And now we're at the spot where we solve the remaining equation. If necessary, multiply both sides by the reciprocal of 3. So we're going to multiply both sides by 1/3. We could say divide by 3 also. Over here it cancels. And on the right we'll have 34/3. So we have x plus 3 squared equals 34 over 1 times 1 over 3 is 34/3. And we're going to take the square root of both sides to cancel the square root. Make sure we put plus or minus over here. And so these cancel. We have x plus 3 equals plus or minus, and we need to simplify the square root of 34 over square root of 3, because we can split this up into the square root of the top over the square root of the bottom. 34, we'll think about this. This can't be simplified because this is 2 times 17, and neither of those simplify. What we need to do here, though, we can't have a square root in the denominator, so we multiply top and bottom by the square root of 3. And that gives us 34 times 3 is 102. So the square root of 102. And root 3 times root 3 is just 3. And so we simplified the square root. This is square root of 102 over 3. And now we can just subtract 3 from both sides. And our answer is x equals, we put the negative 3 first, plus or minus the square root of 102 over 3. So a little more complicated than the first one, not too bad. And our last one, we're going to add another little step of difficulty here. And in fact, what I'm going to do here, just because we haven't seen this yet, I'm going to change this to a minus sign. So we haven't used this, and I want you to see if that's a minus there. All right, so here we go. We're going to solve this equation here. First thing we do is get the x terms on one side and the constant on the other. So we have 4x squared minus 13x. We subtract 9 from both sides to get this. Should have written that first. Equals negative 9. Now what we do, if the leading coefficient isn't 1, it's not. we're going to factor out the leading coefficients. We're going to factor out a 4. And we have x squared, and we go to factor out 4 out of 13, and that is not a factor of, or a, factor of 4. So what we can do, if it doesn't factor easily out of the linear term, then divide that term by the leading coefficient to factor. So this is really going to be minus 13 over 4x. And so in order to, if it doesn't factor out easily, it's just 13 over 4. You can reduce it sometimes if possible, but this one doesn't reduce. And so that's how you get that middle term, that linear term. So we did that. Now we're going to complete the square. So sorry, we still have -9 over here. And so to complete the square, what do? We multiply the linear coefficient, -13/4, times a half, multiply it by a half. So that gives us -13/8. And we're going to square that, -13/8 squared. Negative times negative is positive. 13 times 13 is 169. And 8 times 8 is 64. So we're going to add -13/8 squared here. But whenever we add something to one side, we have to add it to the other. So this 13/8, which is 169/64, was added inside parentheses. So it's not this step. If it says if there was no leading coefficient, which there was, that we had to factor out. So we're down here. If there was a leading coefficient factored out, multiply the value from the step A, which is our 169/64, by the leading coefficient, so times 4. And then we're going to add it to the right side, but let's figure out what this is. So 4 actually reduces, 4 goes into that 16 times, and so we have 169/16. And we have to add that over here. And so the reason we did all that is because now we just added the same thing to both sides. If there were fractions involved, you might need to get a common denominator, and we do, so I'm still going to just keep doing some work over here. I want to add these. So -9 plus 169/16. Well, I need a common denominator here, so I'm going to multiply this by 16/16. If you need to, you can do work on a calculator, but 16 times -9 is -144/16 plus 169/16. And if you combine those, you get 25/16. And so actually on the right here, when we combine those, we have 25/16. Works out pretty nicely, actually, which we'll see later. On the left side, I'm supposed to have this in blue, so 25/16. Over here, we have our 4, and we added in this -13/8 squared, so we would have a perfect square, so this is going to be x. And here, this is where the minus comes in. It's going to be -13/8 squared. So we completed the square. A lot of work there. All of this was in that completing the square step. And now we're going to solve the remaining equation. So if necessary, multiply both sides by the reciprocal of the leading coefficient. So we want to cancel this 4, so we're going to multiply both sides by 1/4, which over here, these reduce. We have x minus 13/8 squared equals 25/64. 16 times 4 is 64. Now we take the square root of both sides. And this is one thing that actually is a little bit helpful. We got plus or minus. Make sure we put plus or minus. Over here, these cancel. And so we have x minus 13/8 equals, and over here, this is the first time this worked out, but the square root of 25, so we have plus or minus. Square root of 25 is 5. We're simplifying the square root here. The square root of 64 is 8. So we didn't end up with an irrational number. We don't have the square root there anymore, which will show us one other thing here. So we're going to add 13/8 to both sides to finish solving. And we get x equals, and we like to put the 13/8 first, plus or minus 5/8. And what we do here is, because this isn't irrational, we can actually add these, and the denominators are actually equal, so we don't even have to get a common denominator. But this means we have two answers. We have 13/8 plus 5/8, and then we have another answer of 13/8 minus 5/8. And so we have two answers. 13 plus 5 is 18/8. 13 minus 5 actually is just as 8/8. And so reducing, reduce by 2, you get 9/4. And 8/8 is 1. So in this case, we have two rational solutions, 9/4 and 1. Now, this happens sometimes. It could have happened in a problem like this, or this. Sometimes it happens that they can simplify. Sometimes it doesn't. But when it does, you want to simplify all the way down to the two rational numbers. So there's 3 examples of completing the square. You shouldn't see anything in any other problems you come across that you wouldn't have seen here.